project manager.
Hi, my name's Stephen Burrier, and I was in charge of CAD and Solid.
Hi, I'm Tommy Rudabaugh, and I'm the Systems and Operations Specialist.
Hi, I'm Shayla Breedlove, and I was the Computer Programming Specialist. During initial brainstorming, we came up with these two designs. The design on the right we decided was too impractical to build, and we scrapped that design early on. One of our first sketches was the cross design. We made this design because it seemed like it would be balanced on the track.
We chose this T design for its balance on the track as well.
This is the flat design, and we chose it because we thought it would minimize the weight.
This is the angled cross design, and we chose this design to perform testing on because seemed like it would be the most aerodynamic.
This is our first SolidWorks design. This is our second SolidWorks design. We went from the angled wings to the flat wings because testing showed that it was more efficient. This is our final SolidWorks design. We minimized weight in this design by choosing 2 wide pieces for the wing instead of 3 wide pieces.
The first problem we encountered in our AEV was getting all the pieces to fit on there. The battery had to be on special plates, so we had to make sure that was there. And the Arduino was not allowed to touch any metal at all. After that, we had to figure out where the magnet would go.
Another issue we saw was in the SolidWorks part of the project. Some of the parts that were given to us weren't lining up quite as we expected, so we just had to adjust our design on the computer.
Another problem we encountered was in the programming of the vehicle. We had a hard time picking the right wheel counts for the different power settings, and where the vehicle went also depended on how much power was in the battery, so we had trouble adjusting to that as well.
Our last problems with the AEV were with the battery. The battery would, after a couple runs, would lose power, so our vehicle would become very inconsistent. In order to fix this problem, we would change the battery out after every 2 runs, but unfortunately doing that would also change, our program would need to be changed a little bit, and we couldn't figure out an exact pattern to it, so we did not meet all the requirements of it.
The first step in our design process was conducted in the wind turbine, where we tested the propellers to see whether the long propellers or the shorter propellers were more efficient. Through our testing, we found that the long propellers were more efficient. We also tested whether or not it was more efficient to use a pull system or a push system. Through our testing, we found that the pull system was more efficient.
The next part of our process was to test the energy usage of the vehicle. We did this by using a sample program that contained all the possible commands. And from this data, we tailored our program to be as energy efficient as possible.
Next, we created a new design to compare to our initial design, and using MATLAB, we found out that the energy usage of the second design was much more efficient than the first one.
The next step in the design process was to make the vehicle meet all the requirements of the track. The requirements were to take the vehicle from the start position all the way to the station. At the station, we stopped for 4 seconds and then continued onto the caboose. At that point, we had to pick up the caboose, wait 6 seconds, and then return to the station. The main lesson that was taught through this project was what it would be like to work in industry and create something, and the process that we would need to do that. Overall, we believe that our process was effective, but we could have made multiple Arduino programs to account for the change in battery. Thank you for your time, and go Bucks!